Hi guys, so today we're going to be doing trigonometry. Okay, so before we get started, let's talk about trigonometry. So the word trigonometry comes from two Greek terms, trigon meaning triangle, you can see why, right, triangle, and metron meaning measure. Okay, so the study of trigonometry involves triangle measurement. Okay? And a ratio of the lengths of sides of a right triangle is called a trigonometric ratio. And the three most common trigonometric ratios are sine, cosine, and tangent, okay? Which we abbreviate into SIN for sine, COS for cosine, and TAN for tangent, okay? To help you remember sine, cosine, and tangent and what they stand for, you might have heard of the word SOHCAHTOA. Right? The SO part tells you about sine, and that sine is the opposite side over the hypotenuse side. The CA part in SOHCAHTOA tells you about cosine, and that cosine is the adjacent side over your hypotenuse side. And the TOA part stands for tangent, which is the opposite side over the adjacent side. Okay, so when we're using trig, we have our right triangle. Okay, and it will be sine of some degree measure, right? So here, you can never have sine, cosine, and tangent of your 90 degrees here when we're talking about it in this way, because then you won't have your hypotenuse, right? The reason why is because here, your hypotenuse is always going to be the side that's across from your right angle, okay? So if this is my angle that I'm talking about, okay, the side opposite to the angle is obviously the opposite, okay? However, if you think about it, you kind of have two adjacents now, right? Okay. However, because this is the hypotenuse, this is across from your 90-degree angle, this cannot be the adjacent, and so the other leg has to be the adjacent, okay? So that's what I often see people get confused about. They mistake the hypotenuse for the adjacent. But again, the thing that determines the hypotenuse is that it's across from the 90-degree angle, okay? Okay, so let's get started with example 1. Okay, we're going to find sine r, cosine r, tangent r, and then we're going to do the same thing but for s. Okay, we're going to express it as a ratio, as a fraction, and as a decimal. Okay, so if this is r, what we want, okay, that would make this the hypotenuse, right, because it's across from the 90-degree angle. Okay, the 4 would be opposite because it's opposite of r. And then the 3 is adjacent because it's next to r. Okay? So then sine r, sine, so that's opposite over hypotenuse, so that would be 4 over 5. Okay? Cosine of r, so if this is the angle we're talking about, cosine ca adjacent over hypotenuse, so that's 3 over 5. Right? And then tangent is the TOA part, so that is opposite over adjacent, so that's 4 over 3. Okay, and then writing them as decimals, that should be easy. So 4/5 is 0.8, 3/5 is 0.6, okay? And then our 4/3 is 1 with the 3 repeated. Okay? That's sine r, cosine r, tangent r. Okay, so now let's do s. So if this is the angle that we're talking about, the hypotenuse stays the same because it's across from the 90-degree angle. But now this would be the opposite, right? Because this is opposite to s. And the 4 this time would be adjacent. Okay, so then if I was doing sine s, so that's so opposite over hypotenuse, so that's 3 over 5. Okay. cosine of s, the adjacent of s is 4 over the hypotenuse, which is 5. And then the tangent this time is opposite over adjacent, 3 over 4. Right? And then let's write their decimals. 3/5 is 0.6, 4/5 is 0.8, and then tangent here is 0.75. And what you can recognize then is for these, they end up being the opposite, right? The sine becomes the cosine is the sine, and the tangent ends up being reciprocal of each other. Okay, so there you go. Okay, so why don't you try CYP1, and then once you're done, come check your answer. Okay, so for sine J, you should have gotten 5 over 13, which is approximately 0.38. Cosine is 12 over 13, which is approximately 0.92, and tangent of J is 5 over 12, which is 0.41, and the 6 repeating. Okay. So sine K is then 12 over 13, which is approximately 0.92. Cosine K is 5 over 13, which is approximately 0.38. And tangent K is 12/5, which is 2.4. Okay. Right, so I would again just label it opposite adjacent hypotenuse and then plug it into SOHCAHTOA. Okay. So example 2 here, you're just using a calculator, shouldn't be that hard. So here, if you look at your calculator, you should look for the sine, cosine, and tangent button. So mine is here, sine, cosine, tangent. And so here, it's just asking to find cosine of 39. So one thing that's important is that as you're using your calculator, especially if you have a scientific calculator or a graphing calculator, right, you want to make sure it's in the right mode. Okay, so here you need to make sure that it's in degree mode rather than radian mode. Okay, so often it'll show up somewhere on the top where it's a D or an R. You want to make sure that it's the D showing, or else you're going to get a completely different answer. If yours does not have the D or the R, or you're on the R and you want to switch to D and you don't know how, please send me an email. Okay, awesome. So here I'm just doing cosine of 39 and rounding it to the nearest 10,000. So all I'm doing is going to press cosine 39, close my parentheses because that's important, especially when it gets more complicated later. Hit equal, and I get 0.777145 blah, 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 blah. Okay, so here we want 10,000. So it's 10th, 100th, 1,000th, 10,000th. That is 4 decimal places. Okay, so cosine of 39, it will be 0.7771. There you go. Okay, so why don't you try check your progress too, and once you're done, come check your answer. Okay, you should have gotten 0.9205. If you got this wrong and you don't know how to use your calculator, please send me an email. Okay? Okay, so the next one we're going to do is example 3. Okay, so here, Dakota is standing on the ground 97 yards from the base of a cliff. Okay. Using a theodolite, he noted that the angle formed by the ground and the line of sight to the top of the hill is 56 degrees. We want to know the height of the cliff to the nearest yard. Okay, so here you can see this is the angle measure. So that would make this x the opposite, okay, and it would make this 97 the adjacent. Okay, so then we ask ourselves, which one uses opposite and adjacent? That is tangent. Okay, so then we're going to set it up as tangent of our angle measure. So tangent of, in this case, 56 is going to equal our opposite times our adjacent. Opposite divided by our adjacent. Okay, so now I need to solve for x. Okay, so since this is x divided by 97, what I'm going to do is I'm going to multiply by 97. Okay, so that means 97 times tangent 56 equals x. Okay, and how we write things is important because that's going to affect probably how we type it into the calculator. Okay, so here I'm going to do in my calculator 97 times tangent of 56. There you go. Okay. It's important that you're closing the parentheses, right? And the reason why I'm doing 97 first rather than doing tangent 56 times 97 is because if I did 56 and then hit times 97 and forgot to close the parentheses after the 56 or something like that, my calculator might misunderstand. So I'm trying to type it in this way so that way it's as clear as possible and there's less possibility for mistakes. Okay. So then I hit equal, and that gives me 143.808, blah, blah, blah. So that means this is approximately 144, because it wants to the nearest yard. So the height of the cliff is 144 yards. The height of the cliff is 144 yards. And there you go. Okay. So why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten that the roller coaster is 43.6 yards or 44 yards, okay? If you got that right, you can move on to our last example. If not, here is your explanation, okay? So I kind of drew a little picture. So Jonathan's standing here. He's 15 yards from the roller coaster here, okay? The angle formed by the ground to the top of the roller coaster is 71 degrees. We want to know how tall the roller coaster is. Okay? So again, if this is my angle, this is opposite, this is adjacent, so that's tangent. So tangent of my angle, 71 degrees, equals the opposite, which is x, over the adjacent, which is 15. Okay? Gonna get rid of the divide by 15 by multiplying 15 on both sides. So 15 times tangent of 71 equals x. Okay, type that into my calculator and I get about 43.6 or 44. Okay, and there you go. Okay, so here is my last example. So here I want to find the measure of angle A in the right triangle. For A, 1, 2, B is 6, 2, and C is 5, 4, right? So here, it's up to you which one you want to use, right? So here we're finding this angle, right? So it's up to you whether you want to find sine, whether you want to use sine, cosine, or tangent, right? Depending on which one you use, then you need to figure out the measures, okay? So this is the right triangle. This would be the hypotenuse. This would be the opposite, and this would be the adjacent. So it's up to you which one you want to use, okay? So the book chose eventually to use cosine, so that's fine. So if we want to use cosine, then we need adjacent and hypotenuse, okay? So then we're going to find the lengths of the adjacent and the hypotenuse. So AC here, which is the adjacent side, okay, is 1 minus 5 squared plus 2 minus 4 squared. Okay. 1 minus 5 squared is negative 4 squared. 2 minus 4 squared is negative 2 squared. Negative 4 squared is 16. 2 squared is 4, so this is square root of 20, which is 2 square root of 5. Okay. AB, the hypotenuse, is nice and easy because it's horizontal. That is 5 units long. Okay. So now what I have with cosine is I have cosine of my angle A is adjacent, which is 2 square root of 5 over 5. Okay. So here I want to get A by itself, the angle A, right? So what I'm going to do is I'm going to do the opposite or the inverse, right? So when we were solving and there's getting rid of addition, we do subtraction. If it was multiplication, we do division. So the opposite of cosine is what we call cosine inverse, okay? So that's just cosine with this, it looks like a negative 1 power, but it's not, okay? So that's cosine inverse. We learned in algebra that what you do to one side, you have to do to the other side, okay? And so what this does is cosine inverse and the cosine cancel, leaving me with just whatever angle A is, cosine inverse of 2 square root of 5 over 5, okay? And depending on your calculator and how advanced it is, it depends on whether or not you can type it all in one go. Okay, so that's what I'm going to do. So here, to find the inverses of sine, cosine, or tangent, okay, you have to find the original button first, and then you should see sine, cosine, and tangent above. Okay, so here on my calculator, they're here in light yellow. So in order to get those, I have to hit shift first and then the button I want. Okay, so cosine inverse is on top of cosine. So to access the cosine inverse, I'm going to hit shift and then the cosine button, and you'll see that cosine inverse pops up. Okay, then I'm going to put in this fraction, so that's 2 square root of 5 over 5. And then I'm going to close the parentheses. And this gives me 26.5, blah, 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 blah. Okay, so that tells me the measure of angle A is approximately 26.6 degrees. And there you go. Okay, and in the book, it shows you that if you used sine, okay, so instead you would find what the opposite is, and you would do the same thing, but you would do sine of whatever this length is over the hypotenuse, and you would then do sine inverse, you would still get the same thing. Okay? Okay, so why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten that measure of angle P is 45 degrees. If you got that right, you can move on to your homework. If not, here is your explanation. Okay, so first of all, whether you use sine, cosine, or tangent, we all should have gotten the same answer. Okay, so don't think, oh, I used sine, that's why I got the wrong answer. That is not why. Okay, it's probably because you made some mistake somewhere along the way. Okay. So I chose tangent, just because we already did cosine, and then I started doing the adjacent, so I had to do opposite for tangent. Okay, so I chose to use tangent. Okay, so here's angle P, graphed it all. Okay, so then this is the hypotenuse. PR is the hypotenuse because it's across from the right angle. QR would be the opposite, and PQ would be the adjacent to angle P. Okay. So then since I chose to use tangent, I need to find the opposite length and the adjacent length. Okay, so starting with the adjacent length, that's PQ, I use the distance formula, right? So 2 minus 4 squared plus negative 1 minus 3 squared. 2 minus 4 is negative 2, negative 1 minus 3 is negative 4. Negative 2 squared is 4, negative 4 squared is 16, 4 plus 16 is 20, so square root of 20 is PQ. Okay, no need to really simplify it or whatever, because eventually we're going to type it in the calculator anyways. Okay. Then, so I have adjacent, I want to use tangent, so the other one I need is opposite. Okay, so the opposite is QR. So same thing, distance formula, 4 minus 8 squared plus 3 minus 1 squared. Okay, 4 minus 8 is negative 4, 3 minus 1 is 2. Negative 4 squared is 16, 2 squared is 4, 16 plus 4 is 20, so QR is square root of 20. Okay, so then, tangent of angle P is going to be opposite over adjacent. So square root of 20 over square root of 20. If you want to simplify this to 1, you absolutely can. Okay. Then I want to get angle P by itself, but right now it has this tangent with it. Okay. So the opposite of tangent is inverse tangent, or tangent inverse, which is written like this. Okay. And what I do to one side, I have to do to the other. Okay. So tangent inverse and tangent cancel, leaving me with just angle P. And then, so then I have tangent inverse of this, the opposite over adjacent I have. If you want, you could have simplified it to 1. Okay. Then in my calculator, I clicked shift tangent, which should give you tangent inverse, or second tangent, depending on what kind of calculator you use. That should give you tangent inverse. So tangent inverse of this, and that gave me 45. Okay. So that's it for today. Have a great rest of the day. Bye, guys.